Hello and welcome everybody to the 15th episode of Tech Life Skills with Tanmay. I hope you're all doing well, hope you're all staying safe. My name is Tanmay Bakshi and thank you for joining today's episode. Now, before we get into today's session, I'd like you all to join me in wishing my friend Sahil Nayak a very happy birthday. I'm sure you're tuned in today and I hope after we're done today's live stream I can get a slice of your birthday cake. Make sure you have lots of fun today. Now, about today's show, we once again have so much interesting stuff to cover. Today, we'll delve deep into the world of robotics. Now, I believe robotics is one of those fields that's just misunderstood, kind of like, and sometimes because of, fields like AI or machine learning. Now, our special guest is none other than the field CTO at ADLINK, a robotics and open source technology enthusiast, Joe Speed. Joe has worked on lots of different robotics applications. He launched IBM IoT, he's built over a dozen advanced technology vehicles, and was even involved in making the MQTT protocol open source and open standard. And that's just the tip of the iceberg as to what Joe has accomplished. And so now, without any further ado, please welcome Joe to the show. Hi, Joe. How are you? Would you like to start off with introducing yourself?
Tanmay, great to see you again. Happy to be here. Great to speak to all of you. I've done a lot on technology, but where I really tend to lean into is the collaboration. So, whatever one person, one organization might accomplish is dwarfed in comparison to what many people working together in a collaboration in a community, and that's why I'm so enthusiastic about what's possible with open source. And so happy to
Absolutely.
talk to you about all of that.
Wonderful. Thank you very much for sharing. Open source technology is definitely really important, and I feel like we've really been able to highlight that importance throughout this series. We actually started the series with Dave Mukherjee from Red Hat, and we talked about the importance of open source and how that enables innovation. We got Sri Ramanujar's thoughts, who are the VP of IBM Research AI and the Chief Scientist of IBM Research, respectively, and their thoughts on why open source is absolutely critical to the field of AI. And now I'd like to get your thoughts on how it's important to the world of robotics and more. But first, I actually want to start off by asking you a question, and that is, how did you get into the world of robotics in the first place? In the first place? Like, what sparked that fascination?
Well, so I came into it from a different direction. I'm a car guy. I'm a gearhead. Until we had children, I had a '63 Mercury Monterey S55, 390 with a four barrel that I had taken apart and put back together myself. And
Wow.
it at IBM, when I was working to take MQTT and make it open source and help people understand what they could use it for, I like cars, and I thought, well, a car is a good way to show off the technology because
Mhm.
it's kind of industrial, because a car is a rolling sensor platform. So
Mhm.
if you can use MQTT to get all the sensor data and publish that to the cloud, then people can understand. Somebody coming from a manufacturing environment or industrial can kind of understand, oh, I understand this. But a car is also a consumer product and has experience. And everyone knows what a car is. If you had some obscure piece of industrial equipment, you couldn't really use that to illustrate what you're doing. But say, everyone knows what a car is. Most people understand them, and a lot of people love them.
Mhm.
So I just got into this pattern of working with many others to build these advanced technology concept cars, which became cognitive cockpit, which became, autonomous vehicles and the HMI for autonomous. And I did a project with UNLV around, could you have an autonomous robot, a humanoid robot that drives a car? And so that's really how
Interesting.
I come into this whole area.
That is really fascinating. Having an autonomous, a humanoid robot driving an autonomous car, driving a car to make it autonomous. That's something that's weird to
Absolutely.
think about.
So who needs a self-driving car when your autonomous robot can just drive it for you?
That is
And I
incredible.
can I can I can show you some pictures and video of it later.
I would love to see that. Actually, the question that I have for that really quickly before we move on, what was the point of that project? Was it purely to see if we could get it to be done? Was there really, what's the advantage to having, a robot drive the car for you?
Um, you know, for me, a lot of it is sometimes, could we? And if we
Yeah.
could, then we must. Uh, For that one, so that's part of the DRC Hubo program, which are it's a DARPA challenge for humanoid robots to go into situations that are too dangerous for humans and do things that humans could do, right? So, for sake of argument, like in a chemical plant or something, if there's an issue, could you send a robot in to close valves, pull levers,
Hmm.
things like that? And so part of the challenge was for these humanoid robots to actually drive into these situations. And so
Fascinating.
that's how we supported the UNLV school. My friends at Local Motors, Gene O'Connell, they 3D printed an electric golf cart, basically, right? Like a
Wow.
neighborhood electric vehicle for the robot, and designed it around the robot. And then I got IBM to chip in some, basically help fund the school for them to teach it how to drive that vehicle.
Wow, that is really fascinating. The reason that I asked you what the advantage was is because if you, the people joining the live stream right now, if you've watched the very first episode we ever did on the Tech Time with Tanmay series, with Rob High, who is the former,
Oh,
former CTO of IBM Watson, now CTO of IBM Edge Computing, and also an
yep,
IBM
yep.
fellow. One of the things that he always
Tell Rob I
says.
said hi.
Yeah, wonderful. I will do that. And when we were doing that episode, one of the key things that Rob mentioned, and this is something that I've heard him say a lot of times, and I feel like this is really important, is that you always want to fine tune the technology you're building to work in where it is that you're going to be applying it. And like
Mhm.
for example, when it comes to like AGI, artificial general intelligence, Rob says it's not really a matter of could it be done, it's a matter of do businesses really need it, are they going to invest in it, why would we want to replicate the same limitations that humans have within technology? But here you are coming out with this new angle saying, even though technically we are creating a humanoid robot with some similar limitations to humans, at the same time those robots have other applications, and so in this case it makes sense to actually have that robot drive, right? So
Mhm.
it's really interesting to see that new angle on that, which on the surface might seem like why would you have a robot drive? There is a real reason to it. So that's really fascinating to hear. And now I want to talk, since we're on the topic of humanoid robots, I want to talk about the world of AI and machine learning and kind of how it intersects with robotics. Now, I kind of feel like machine learning and AI, of course, they're very misunderstood fields, but robotics alongside them is also quite
Mhm.
misunderstood. And people think of, when I say the word robot, you think of a couple of different things. Maybe you would think of the kind of machines that would take away your jobs, or maybe you would think of like a humanoid robot like Sophia or like the Terminator or things like this. That's
Yeah.
like the first few pictures that pop into people's minds. But robotics is way more than just that. Those are specific niches. Some of those are a little more exaggerated than others, I would say, from a technology standpoint. But can you give us a bit of a clearer picture of what robotics actually looks like today?
Well, it's a very diverse field. The areas where I tend to work are more around the industrial and autonomous mobile. And when you say autonomous, people automatically think of autonomous driving, things moving around. You can also have robots that are completely autonomous that are actually bolted down to a table, right?
Mm-hmm.
And so it's just do they have the intelligence uh, to make their to do the task independently, make their own decisions. And the part of it where I took focus is, like I said, more of the autonomous driving. And autonomous driving is an interesting one because uh, I really draw no distinction between an iRobot Roomba at one end of the spectrum and a passenger vehicle on the highway at the other end of the spectrum. To
Mm-hmm.
me, these are that is the continuum, and there are 1,000 points in between, and many interesting things exist between those two extremes. And for me, it's a matter of scale. So the richness of the sensor suite, right? Uh, the bandwidth, the complexity, the number of sensors varies. Uh, the compute to deal with them, the kinds of compute technology that you bring to bear varies, right? Because at one of the spectrum you have you know very small, low power ARM, and at the other end of the spectrum you get into some much more higher end compute, GPU, GPU, EPU, TPU, NPU, all these hardware. Basically, in this context, it's hardware accelerated ML and sensor processing. And you scale the risk, right? So the risk of an iRobot compared as you go down the continuum to a passenger vehicle on the highway, the risk is very different as well. So those are the things that scale: the sensor suite, the compute, the risk, and one of the things I think is really great is so like the folks we work with at iRobot, when they do something to ROS2 to make it faster, more efficient, more reliable in their compute, in their robot, those changes, if they make it twice as fast, well, that makes it twice as fast no matter what your compute platform is, right? And so it's great because we have people doing these things in the autonomous driving front that are directly contributing to all of the other robots working better, being easier, more reliable. We have people doing things at the smaller, like maker end, that percolate up the other way, and we just have this amazing communities between the Eclipse Cyclone DBS ROS middleware, which is built into ROS2. ROS2, so ROS, which robot operating system, which is neither a robot nor an operating system, but is a framework and tools for developing robotics applications. And then ROS is built into AutoWare, and AutoWare is the open source autonomous driving. And Open Robotics is a member of Eclipse, and Eclipse is joining AutoWare, and AutoWare is joining Eclipse, and it's just this amazing where you get these clusters of communities that all come together to help all the humans.
Wow, that is really fascinating, and I don't think I've ever heard anybody comparing a Roomba to like a Tesla and like self-driving cars, and it's interesting to see that continuum because when you mention it, it makes a lot of sense, right? We're scaling everything up all the way from the compute platforms to the risk to the complexity of the software and the hardware. Everything's being scaled. And they both sort of rely on that same fundamental framework of tooling, right? You mentioned ROS, for example. ROS is, as you mentioned, the open source robot operating system, and I'd never heard of this until we had talked a little bit about that, and the fact that it's called robot operating system, but it's not a robot, neither an operating system. Can you tell us a little bit more about what ROS is? What does it enable you to do? Why would you want to use it? That kind of thing.
Yeah, so it's an architecture, it's packages, it's tools, it's tutorials and samples, but probably most importantly is its community. So you look at like the last release of ROS2, which is ROS re-architected for supporting some of these more complex, more challenging use cases. So swarming, safe, distributed, performant, all these sorts of things. But the community is amazing, right? We had 115 engineers that contributed to this last release. If you look at ROS in whole, there's thousands of people that contribute to that. It's what's taught at every university worldwide, and it's the basis of most. I would say right now today, every new mobile robot that appears in the world is running ROS. So you see like all of the robots that are dealing with COVID, right? The sanitation, the UV robots, all of those are running ROS. And in autonomous driving programs. So, most autonomous driving programs are in fact using ROS or ROS2 or base or using pieces of it. And those that say that they aren't are usually lying.
That is really interesting. I mean, is there a reason they would want to lie and not talk about the fact that they're using ROS?
Yeah, well, not everyone's bought into open source, so they want to take advantage. They want to consume, but they don't contribute, and they want to market that they have their secret sauce, right? That they haven't really come around to understanding the value that you can in fact monetize open source. And I think Red Hat's a good example of they monetize to the tune of some $38 billion, right?
Yeah.
It's So you can make all of your work open. You can give it away to the world, but there are still ways to make an income from that, either as an individual or for your company.
Very nice. And I feel like there are many different examples. You mentioned Red Hat. Another one I think actually is IBM Power is a really good example, because if you take a look at, for example, I think the only major company doing this right now is Raptor Computing Systems. They
Mhm.
have hardware and software which is top to bottom open source. Like, I'm talking down from the BIOS firmware to the operating system and all the tools on it, down to the
Yep.
ISA of power. Everything is open source. Everything can be modified or touched by you in some way. And people are actually willing to pay more to buy into a platform like that, because they have that open source control, because they can
Mhm.
contribute, because they have access to do whatever it is that they want to
Sure.
do with those machines, right? So you're right. Open source is so pervasive. I would say almost every single piece of technology touches open source in at least some way, right? You take a look at all of Apple's operating systems powered by open source technology in the back end, Darwin. You take BSD in the back end, really. You take a look at another great example, Watson, that played Jeopardy. A lot of the different technology that went behind Watson playing Jeopardy is open source. Of course, there's a lot of little secret sauce putting things together that IBM did that's proprietary, but a lot
Yeah.
of that is open source tech. Um,
And in the case of Watson, you use a lot of open source tech, but the whole thing gets packaged and basically shrink wrapped, right?
Yeah, yeah.
Um, the like what I like is the approach. So our friends at Box Robotics in Philadelphia, what
Hmm.
they're doing is a what they call warehouse HD. They're doing an HD perception for mobile robots,
Okay.
and what they are working on is that if a mobile robot in a factory or warehouse can drive twice as fast and do it safely, you can save 35% on the fleet cost. Okay? Or even more interestingly, you look at, because of COVID, you have this acceleration of the shift from storefront to e-commerce. And what it means is the existing distribution centers and warehouses are overloaded, overwhelmed,
Hmm.
and they're also having trouble having enough workers. So if you can increase the throughput of your autonomous forklift, pallet jack, AGV, AMR fleet, that's a real benefit to everybody. And so they're doing something really interesting here, which is they do have proprietary commercial software, but where it fits is at the top of the stack, and they work with the community to make ROS 2 behave better, be more performant, lower latency, less jitter, to make the underlying middleware, the Eclipse Cyclone DDS, more performant. They work with Ouster to have the LiDAR driver and iterate on that to be just extremely, fast, efficient, jitter-free,
Mm.
low jitter. Um, so here you have a company that, yes, they do have a piece that's commercial software, but they're also actively working to renovate the entire stack for this use case, for this, what you call an operational design domain.
You
So I
know,
think that's a really interesting one. You've got a commercial bit, but you're also improving all of the open source that lies beneath it.
I feel like there are actually quite a few different examples of this throughout different industries, and I feel like one that is a lot more immediately noticeable by a lot of developers, and I feel like would be a good analogy to what you mentioned in
Mm-hmm.
robotics, is the entire LLVM project, basically. Because if you
Mm-hmm.
take a look at that stack, the LLVM compiler itself is open source, right? Anybody can
Mm-hmm.
add to it,
Sure.
modify from it, distribute it, whatever. On top of that, you've got different front ends like Clang and the Swift compiler. Both of those are open source. But then Apple specifically is developing Swift, and they're developing their own frameworks on top of it, like Foundation and like Swift UI, that are proprietary, that are specific for Apple platforms, and that's where they make their money. But then you've
Sure.
also got those open source bits like the Swift compiler and the LLVM backend. And when they want to add something, like an amazing new feature in their Swift UI front end or their proprietary bit, those changes propagate throughout the stack, right? It's making the entire open source community better as well.
Mm-hmm.
Swift for TensorFlow is a great example of this, right? Either they're working on this new MLIR project that makes it so that every compiler front end that uses LLVM can benefit from the same optimizations at the intermediate representations.
Mm.
And so this is
Wow.
something that, was unimaginable without not only open source technology, but a centralized community where everybody's coming together, and there's not like, everybody has their own open source compiler standard, right? That's not how it works. We would be nowhere today if LLVM didn't exist as that one place where all different languages and communities come together to say, this is the one thing we can agree on, right? So I would say open source is important across industries. In AI, it's fueling innovation. In compilers, it's enabling us to write high performance software. And with robotics, as you mentioned, it's enabling these communities to come together to build on top of each other's work. So, really incredible stuff. Now,
And they fit nicely together too. So like, computer vision is very interesting for me. I do some work on that. Robotics is very interesting, but when you put the two together, you get things like, camera on wheels, right? Mobile vision, where instead of bringing the thing to the camera to be inspected, the camera can go to the thing.
yes,
And what you see happening in, for computer vision, just by default, almost everyone uses OpenCV. Okay. And so people have integrated, you got the Tensor, all the TensorLite, TensorFlow, TensorRT, the PyTorch, all these things integrated, hardware acceleration optimizations around NVIDIA GPUs, Intel Movidius, Miradex, all these things. So in Open Robotics, what you do is you take the OpenCV and you plug that into your robotics framework and you use the two together. And it's it's a great thing when you can find the synergies, and instead of being so naive or arrogant as to say I'm going to invent my own technology. My whole career I've always been a best of breed technology, and I love how we see that in the open source community, where it's an assembly of the best of breed open source technologies.
absolutely. It's putting together all those little open source bits and pieces to make an amazing final piece of
Yeah,
software. And
which is
piece of
not
hardware.
necessarily easy. So
Yeah, no,
Open
totally.
Robotics has, they've got a staff. Pick a number, right? If they have 40 engineers on staff, just basically contributing and coordinating all of these contributions. So like reviewing pull requests and giving comments back and integrating and testing and nightly CI and cutting the release and all of these, the release management.
Hmm.
It's a big job because they're at the middle of a community of thousands of people around the
Hmm.
world. And
Absolutely.
let me rephrase, thousands of contributors, millions of users.
Wow.
So Ross had 264 million downloads last year, and we're on track to around 500 million for 2020.
Wow. That is really incredible. Half a
Yeah,
billion
yeah.
dollars by the end of 2020. And what really specifically fascinates me is, I mean, you mentioned that it sounds a lot easier than it actually is to be working with this open source technology. People would think you're just putting together the different bits and pieces, but there are millions of different possible permutations of how different technologies can fit with each other. The entire point of what the engineers and what the developers are doing here is actually putting in that creativity and that problem solving skill to be able to say, all right, we've got these tools, this is how we're going to use them, this is how we're going to use them to solve our problem, this is how we're going to contribute back to them to enable them to solve our problems, right? So there's all sorts
Yeah.
of stuff going on here.
But there's some really interesting open source that helps with that problem as
Yeah,
well.
yeah.
So things like Docker. So you look at AutoWare. So AutoWare is autonomous driving for ROS. Um, so AutoWare is built on top of ROS. ROS is built on top of DDS middleware. The one that we work with and contribute, the Eclipse Cyclone DDS is built into that. So you've got Eclipse Foundation DDS built into Open Robotics, built into AutoWare. And then AutoWare, so you can do your driving simulation and testing. They use the LG Silicon Valley Lab
Hmm.
open source sim, and that is built on Unity 3D. And so this is a lot of pieces. So what they do is they package the whole thing together as a Docker. And so you want to try doing, autonomous driving development for a vehicle. You just grab the Docker, and all the tools, all the bits already in there, and all of them have already been integrated, tested, documented, tutorials, all of it.
Wow, that is incredible. when I started using Docker for the first time a couple of years ago, I used to think, how did anybody get anything done before Docker? Right? Because
It's true.
it really is a lifesaver, right? It's something that today we can't live without, and I think we take for granted. You know,
Yeah.
it's really some incredible technology, and the fact that it's all open source, the fact that we can all modify it or contribute to it is really incredible. Now you were mentioning computer vision technology and how you're really interested in
Mhm.
like that aspect of tying in machine
Sure.
learning with robotics. And what I've been wondering is, what more modern machine learning technology enables us to do, or deep learning technology, as we like to call it, is it enables us to sort of leverage and extract insight from unstructured data, right? So it enables us to take things like auditory or visual or linguistic data that previously we would say, this is something that humans deal with. We can now leverage the power of technology to deal with it or to understand it or to extract valuable insight from. And then there's also the world of regular old machine learning where we're dealing with tabular data like data from sensors, right?
Mhm.
And or well, it depends on the sensor, but things like accelerometers and gyroscopes where the data
Sure,
is
sure.
tabular numbers. So could you give me a bit of a better idea of where machine learning exactly intersects with the field of robotics, and alongside that, how much data are these robots or these robotics, sort of applications really generating? And of that data, how much of it is really unstructured, something that we use deep learning tech for,
Yeah.
versus structured, something that we're using, regular old ML for?
Yeah. So in open robotics, so in the open robotics core, like what gets released, what everyone downloads and uses, right now today, there's not that much ML built in. Okay. There's a lot of people who do prototyping, one of a kind, where they use ML, or maybe they use ML in their commercial product, where they take open robotics and then they build their commercial product and the additional things on top of it. Um, a lot of that doesn't get contributed back to the community, or some of it does is a bit orphaned, right? So if it's interesting if you develop a ML package and you make it open source, it's much more interesting if you sit down and take the time to work out how do we build this into the default standard ROS perception package and build it into that and do the pull request and support that.
Mm-hmm.
We're getting more of that now. So I lead the Open Robotics ROS2 Edge AI working group. So I'm working with a number of individuals, a number of companies, uh, some really interesting things happening there, more of it coming into open robotics. And uh, so, I think you're going to see a lot more of that. The number one place where it does get used today is perception. So vision and all the forms that vision takes. There's been a good amount of work over there, and because we are able to plug OpenCV into loss perception, that's the way in for most of it. There is some really interesting, exciting work going on with Dave Coleman, Picnic, and the Move It team. So Move It is path planning, typically for robot arms. So if you have a object, so I've 3D printed an object and it has all the rough bits.
Mm-hmm.
How do we figure out the path plan? How do you do the path planning to figure out the optimal machining to arrive at the finished product? And they're doing a lot with ML to actually to iterate and generate that path plan so you can get the optimal kind of CNC. In direct digital manufacturing, everyone talks about printers, but really there's two things. You have additive and subtractive.
Mm-hmm.
So first you add the material and then you subtract the material. And the subtractive is where a lot of this is happening.
Very interesting to hear. Now, just before we continue and before we get deeper into what you just mentioned, I do want to take a bit of a detour. And the reason I want to take that detour is because there's a little bit of a conversation that I see a couple of people are having on LinkedIn. Specifically, I think Jill and Neil are talking about something, and I feel like it's really interesting, and I wanted to get your thoughts on it.
Sure.
And they are talking about the advantages versus the disadvantages of having more and more of these tasks actually offloaded to robots or to AI in general,
Hmm.
I think,
Yeah.
versus us doing them ourselves, right? I mean, Neil brought up an interesting point. Before the invention of the calculator, many of we did a lot of these advanced calculations ourselves, but now with calculators, even basic ones we're offloading to
Hmm.
calculators. But there's pros and cons to everything, which is what Jill's brought up, and I definitely have a few thoughts on this that I want to share. But first, Joe, I wanted to get your thoughts. Neil over here is mentioning that on one hand we don't have enough jobs, but on the other hand we're using robots to replace different jobs. So, what exactly are your thoughts on that?
Well, in a lot of areas, you don't have enough people or enough people with the right skill, or the people with the right skill don't have enough hours. So, I always think of the robots as, the robots are here to help the humans. Okay. And you want to look around for, like, where there's a good example of that. One of the best, one I'm absolutely in love with, is Changi General Hospital in Singapore. It's a project. They have a program now called Chart, which is led by a delightful lady, and that's part of Singapore GovTech. So Singapore, more than almost any country in the world, invest in a lot of these kind of advanced technology automation. So when you're in a hospital, one of the issues is the nurses only get to spend a little bit of time with the patients, right?
Mm-hmm.
And I forget the exact percentage, but it's like a quarter of their time or less,
Mm-hmm.
because the rest of the time they're doing paperwork, they're resupplying. The patient needs something, so you know they're going to the storeroom to fetch material, or they're restocking the storeroom, and so there's all of these tasks that nurses are doing that don't include face-to-face time with patients.
Mm-hmm.
If we can automate those functions, right? If you can automate it such that the nurse's bedside, the nurse is working with a patient, and whatever the nurse needs arrives to her or him at the exact moment they need it, what does that do for the patient care?
Mm-hmm.
And a nurse is a it's a very highly trained person, and you can't suddenly just say, oh, I want to double my nurse workforce, right? That
Mm-hmm.
it's not so easy. So, I think if you approach it from that perspective, there's a lot of benefit, a lot of help that it can give. It's
Absolutely.
in the DSRC Hubo program. A lot of these programs, they kind of in one of the programs that Southwest Research Institute is doing with Boeing and the Air Force on refurbishing airplanes. They talk about the 3Ds. So any job that is dull, dirty, or dangerous, those are good candidates for robots. And so, for example, with military aircraft, when you go to refinish them, you have to grind the paint off of the airplane, and it's a very exacting job, because if you go too deep, you go right through the aluminum, right? And it turns out these paints are made of exactly the materials you never ever want to breathe in. So, that's like, no human should be doing that job.
Mm-hmm. Very interesting. So, you're right. The jobs that are dull, dirty, and dangerous. I feel like that's a good acronym to give it. And from the very beginning, I've always been talking about the fact that with machine learning and AI, especially, and
Hmm.
technology in general, we're not really replacing humans. What we're doing is we're putting humans where they should be, right?
Hmm.
And I feel like what you mentioned is literally exactly that. And even if we go back a couple of episodes to my episode with Dr. Shuffy, who's a world-renowned cancer surgeon. In fact, Time magazine calls him the world's most watched cancer surgeon. Right? He live streams his surgeries in VR. And what's incredible is that he's using robotics technology for his surgery.
Hmm.
Robotics is very pervasive within the field of healthcare. He's using advanced AI-driven robotics as well. And what he believes is that this technology is bringing out the more human side in us. And I absolutely agree with that. Neil, you mentioned that the motive behind this technology is because humans want everything to be done fast. and want a more luxurious lifestyle. But I would say that it's not necessarily that we want luxury, it's that we want to be applied in the fields where we were meant to be applied, right? You
Mhm.
mentioned that we're not interested in physical work. I wouldn't say it's that we're not interested in it, it's that we were never built for it, right? If you look at
Mhm.
how humans evolved, we never evolved to drive cars. We're one of the only animals with blind spots in our eyes. Okay, you take a look at the study from Oxford, and they did this little research where they were like, okay, if we were to naturally select humans or artificially select humans for the next X generations based off of just
Yeah.
how likely they are to survive a car crash, that doesn't look like a human to me, or at least a Homo sapien. So we as humans haven't evolved to do easily over half of the tasks that we have to do to keep the economy running today. And so the point behind this advanced technology is to make it so that humans are applied in fields only where it requires our extremely unique, intellect that no other
Mhm.
animal seems to have, versus the brute strength or the brute, physical work that computers and other things can sort of take up for us at this point. So I would say that it's not that we don't want to do physical work, it's that we were never meant to do physical work, and we've had to because there was no technology to do it for us. But as we slowly sort of add this technology in, we're going to start to change what it means to work, requiring innovation, requiring creativity, and we're going to see a change in that sort of the way we look at work. So things are changing at a very rapid pace right now, which is why I would say we have all these different opinions on where things are. But soon we're going to start to see more and more people come to different realizations about where this technology is being applied. So I'm actually currently working on a really interesting application around demonstrating how exactly machine learning is meant to augment creativity. So do stay tuned for that.
Yeah.
But yeah, that was a really interesting detour. If the either of you do have more questions or want to or want to have discuss something else, feel free to put that in the chat. I would love to get into that, and we will be doing a more dedicated live Q&A towards the end of today's session. But right now, Joe, there is another question that I want to ask you, and that is,
Okay.
we've talked about a couple different applications within the world of robotics. What are some of those programs or applications that you are specifically very excited about?
The so I think you've seen some of the things around the accessible Holly. So, I have myself and a lot of friends of mine. Let's just call it accessible transportation. So the me and many of my friends, we believe very much in transportation, public transportation, making it autonomous, making it safe. But we see some real issues in terms of if you're elderly, if you're disabled, um, if that the transportation has not been designed for you. So a lot of us banded together to do something, try to do something about it, to really show others what's possible. And it's fortunate, this is me and all my friends, but we all work for amazing entities who believe in us and back and support our work. And and so I had started the IBM Automotive Lab, along with some friends there, and the Auto Lab, and the the and so one of the projects we were doing was around this. If we make a self-driving, an open source, crowdsourced open source bus for elderly disabled. ADLINK was a partner. They were recruiting me to join, and I said, "Well, I'd love to, but I'm too committed to this program." And but ADLINK, which is just amazing, they say, "Oh no, we love that. Why don't you join and you can keep working on it full time, and we'll give you a roboticist, we'll give you technology, we'll give you money to do this." And so that's how I came to do ADLINK, working with IBM on this program instead of at IBM. And but we launched that at CES a couple years ago, and we developed it with MIT, Princeton. Had developed as part of the MIT Assistive Technology Hack, the AP Hack. Had developed it as part of Hack Princeton. Arizona State University contributed to the ramp design, the engineering around that. We had LG, Panasonic working together, and many others. And the LG Panasonic is an interesting one because when you have these initiatives that are just bigger than any of us, right? Whether it's about uh, whether it's about, social issues or helping the disenfranchised, those at disadvantage, climate, environmental, all these kinds of things. Panasonic and LG are in the wild, they are natural mortal enemies, right? They compete. But this project, doing this work was important enough to them that you had LG engineers and Panasonic engineers together in the same bus, integrating their equipments together
Wow.
to do these things, to make it accessible. And that's what I really like to see. And so, you see that in open robotics, with people coming together. So assistive technology, autonomous wheelchair, autonomous transportation, all of these things. I'm really into that. And ADLINK, is an amazing company, really good at heart. So, like, it's not an assistive use case, but just think about how we think. When Hurricane Maria hit Puerto Rico, we landed engineers in Puerto Rico to connect FEMA emergency generators to the cloud so that we could get schools open and get hospitals reopened.
Wow.
Yeah.
That is really interesting to hear about. So many impactful examples of
Yeah.
robotics in the
So
world.
I like that. And then, just because I'm a car guy, I like things that drive fast.
Yeah.
So how do you do high-speed autonomous driving? And so I've been helping, doing some things, for example, with the University of Hawaii in Maui. They're really, really great people, really great school, and so I love helping them with this. And let me show you that.
Sure, I'd love to see.
Share screen, and so so what they've done is they've taken an EV cart, so an electric race car, does about 60 miles an hour, 100 kilometers per hour, and they've installed a drive-by-wire system so they can remote control teleoperate it. So you can have a safety driver in the vehicle, or you can drive it remotely.
Wow.
And you can let Ross drive the car. So, so think about, you could hop in and do a ride along as Open Robotics drives you at 60 miles an hour.
Wow.
And here they are doing some testing. And, look at it. It's Maui, it's palm trees, it's ocean.
Yeah.
It's beautiful. So I'm spending a lot more time on these kind of high-speed autonomous driving topics.
Very nice. I'm sure a lot of people would definitely be interested in that sort of high-speed autonomous vehicles. That's so. What's amazing is that this technology, all based on the same fundamental platform, can be so fun and so entertaining, but at the same time so incredibly useful and impactful. Helping us with COVID. In fact, I want to get to COVID in a moment, but there are two things that I want to cover before that. First of all, you mentioned accessible Ollie, and that is a huge undertaking. You've got LG and Panasonic engineers working together. You've got IBM on it. You've got ADLINK.
Yep.
This is a multi-organization. This is a project bigger than the sum of its individual company parts.
Yeah.
And so I wanted to get your opinion or your thoughts, maybe your experiences on how do you get such a large-scale collaboration to work in the first place, right? And I know that your answer's going to be specific to this robotics example, but I feel like that advice could be applied practically anywhere.
Yeah, it takes a bit of skill, a bit of practice, but most importantly, it's just your mindset, your attitude. So, I'm always very inclusive, very generous. I share the ideas, I share the credit, I bring people in, and make them part of it. And I've done that my whole career, right? So, I spent decades working on open standards, and from open standards, I got into open source, and I got into open robotics, open source autonomous driving, all these things. And we had practice, right? So before we get to accessible Ollie, we already had, Gene O'Connell at Local Motors and others working with me and the people at IBM around how do we do an AI-driven cognitive HMI for autonomous vehicles. So when you have an autonomous bus, the bus driver does more than just drive the bus, right? They tell you where you are, tell you where you're going, help you get on, help you get off, all these things. what's the AI equivalent to that?
Hmm.
And it's but really you just have to be open, be friendly, be helpful. Okay. You look at like a project I'm deeply involved in around the open source Eclipse Foundation middleware for open robotics and AutoWare, the Eclipse Cyclone GDS. We have an amazing inventor and lead committer for that, Eric Lasan, where, like he loves just waking up in the morning and people have questions, issues, contributions, like people are engaged, and this is via GitHub typically, and he's working with them, and because of how he and that team and the other contributors work with the community, that community keeps getting bigger and bigger. And so just for example,
Hmm.
you talk about something that's a relatively new project, and yet, if you look just at the public adopters, and this is tip of the iceberg, right? But uh, so these are some of the organizations that publicly adopt and support the Eclipse Cyclone GDS project for
Wow.
open robotics. And we have a lot of great contributions. So, there's been contribution from iRobot and Bosch and Amazon Web Services, the RoboMaker team, and Open Robotics and AutoWare, and Robotech AI, working with LG on simulation for autonomous driving. Box Robotics, working with Alster LiDAR on renovating that entire ROS2 stack for high performance, high speed, safe autonomous driving. There's people doing stuff as things that swim, things that fly, things that walk, things that roll. Um, it's an exciting time.
Very nice. Yeah, it's really interesting to see that all these different companies are coming together to be able to contribute to that one project.
Yeah, yeah, it's great stuff. And the accessible Ollie, you know, the like I mentioned, there's these companies involved, but more important are the individuals at those companies.
Hmm.
And you see, like, the IBM sponsored PTech Carver, getting the students involved and doing the students at PTech Carver in Baltimore contributed to the design. And what was really amazing is, my team of kids, they chose Stevie Wonder as their design persona,
Hmm.
and uh, yeah, the Zoom puts its handle exactly where the
Oh yeah.
browser is this thing. So these are kids that I worked with on this, and so my team kids chose Stevie Wonder as the design persona. So in design thinking,
Hmm.
what am I thinking? What am I doing? What am I saying? What am I feeling? All these kinds of things, right? And but it was just great that we actually had Stevie Wonder come and
Oh,
see what my team of kids did.
very nice.
And yeah, so that was pretty great. Of course, I did have to explain to one of the engineers from Amazon Web Services who Stevie Wonder is, and so
Interesting.
uh, so and the connectedness of it, like one of the crazy things here is so our friend Mike May, he's a famous blind engineer. He designed an assistive GPS, basically think like a hearing aid that can navigate you through a city. So Mike May shows up at our exhibit at CES, and he says, Joe, I want to introduce you to my friend Stevie. I brought Stevie to experience what your kids designed for him. And, we've been working with Mike May on this project for a while, and, you know, who knew that he's buddies with Stevie Wonder?
That is really incredible.
Yeah, yeah. So it's fun stuff.
Yeah. This
But
goes.
everyone's, you got to find find a project like that, right? Find a passion. And this one, I'm pretty proud that it actually resulted in language being contributed uh, to legislation in the House and Senate around what are the implications of autonomy for
Wow.
the elderly and disabled. So, it's it's, you see all these projects that I think of as like son of accessible Ollie, where these assistive technology, transportation, autonomous mobility for elderly, and many of these projects were directly inspired by this work.
Very nice. That is so fascinating to hear. Taking a look at how the Accessible Ollie project, which is all these different engineers, all these different individuals coming together from all
Yeah.
these different backgrounds, sort of in a way pioneered this sort of enabling us to look at, okay, what does autonomy really mean for the future of society, right? Sort of
Sure,
kicking off
sure.
that, giving that initial spark to the field, and I can't wait to see where the project goes from here. As a matter
Well,
of fact, yes, go ahead.
I'll just show you one more thing. It's maybe a little early to be talking about it, but what the hell? Is so there will eventually be some some press and things around it, but I'll just give you a preview. Um, so Kentrans, they did the work teaching the bus how to speak American Sign Language,
Mm-hmm.
and the oh god, this video is long. Yeah, let's skip that one. The so what we're doing is we're in a program. So ADLINK manufactured special hardware accelerated edge AI hardware that's being used with the Azure Connect Depth Camera, and 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 what's happening is uh, Line Dance AI, this in their Kentrans project, is developing the world's largest database of 3D gestures of American Sign Language.
Wow.
So, fast forward a bit and think about, in the future, any depth camera that is connected to the cloud will be able to interpret American Sign Language.
That is amazing. We've seen so much innovation within AI only after we've seen large databases, like, for example, ImageNet open sourced.
Hmm.
And I think this is going to be the start of innovation for, using depth cameras to understand
Yeah,
not just written and spoken natural language, but
sure.
even signed language.
So think about getting to where you have model zoos that can interpret the sign language of, each country, each language.
Amazing. Even just in the last episode of Tech Life Skills with Tanmay, we had this amazing question around, like, what's the difference between using machine learning to understand written versus sign versus
Hmm.
natural, spoken natural language. I
Yeah.
feel like this exactly answered that question. So, thank you for sharing. But then again, even though this data is there, we've got the machine learning, we've got the robotics. There is another technology that I think ties all of this together and enables sort of the communication to happen between them and enables the development for all of them,
Hmm.
and that is cloud. So, how exactly does cloud fit into the picture, and where is cloud used in the world of robotics? And you can answer that question, but I also want to
Yeah.
specify to machine learning and how that ties into the cloud as well. But go ahead.
Yeah. So, cloud is a useful thing, right? It's good that it exists, but, you know, for a lot of people, they look at it as, it's a hammer and every problem's a nail, right? Not every problem fits cloud. And so when I was at IBM, I launched IBM IoT, got MQTT made open, and I saw a lot of value that, the data is generated at the edge, right? So how could you move the analytics to be in, on, or near the thing? Because the thing, the edge, is where the events occur, where the data is generated. And so I was pushing inside IBM to, let's take all of our analytics technologies and move them to the embedded systems. And I got a bit of pushback. You had people who were just trying to get their head around, executives who were just trying to understand, like, what is cloud? Like, they had just been assigned to run, like, cloud, and I was already post-cloud. And so, that was told that what I was trying to do was an existential threat to the IBM cloud business.
Oh,
So I went to Linux Foundation and did that for Jim Zimmerman and the Linux Foundation instead. the so the where it sits today, cloud has a role, but I think it's a very specific thing. The When you're talking about machine learning, training models is computationally expensive.
mm-hmm,
Inference, running the models, is computationally cheap,
mm-hmm.
inexpensive. So training the model is something you do occasionally. and the inference is something that you're doing constantly. So what you arrive at, a pretty normal thing now, is you put your equipment at the edge, your sensors, your cameras, all of this. You collect your data, and then that constitutes your training set for the machine learning. And then you bring that training set to the cloud, okay, where it can be, annotated, tagged, and used to train the models. So you think about, train in the cloud, run at the edge. So you bring your data up to the cloud, train your model in the cloud, and then deploy and manage that to the edge. For a lot of things that we deal with, right, for industrial vehicles, aerospace, other things, even if you have access to the cloud, to bring data to the cloud to make a decision and bring the decision back is too slow, right? You've ruined the part, you've broken the machine, you've burned the building down, you've injured the person. And but where the cloud is really good is when I think about fleets of things. So for example, at the edge, you can do the analytics in the vehicle to say, what is the health of this vehicle? But then that vehicle, along with thousands or millions of other vehicles all connected to the cloud, now I can look and know something about, what's the health of the fleet, what trends can I see? Because, the more data you get, the better decision you can do. And so if I can do my analysis across the entire fleet, that's much more interesting, much more useful. So the monitoring, the management, the deployment, developed and test, like in robotics, there's a lot of, you design and develop and test in simulation. Because if you're building a new prototype robot for your startup, you maybe have one prototype and you have a task that you want to teach the robot that takes 1,000 hours. Well, instead of setting aside my robot for 1,000 hours, what if I just spin up 100 of them in simulation on the cloud and I do it in 10 hours? So that's another place where we see it.
That is really interesting because we actually see this in the real world with Google and Waymo, right? And how they're creating these realistic environments in which they're training their self-driving cars. You take a look at OpenAI.
Oh, yeah. So Waymo has driven millions of miles in the real and billions in simulation.
Wow. And first of all, that's incredible, billions of miles in simulation. But also at the same time, if you take a look at OpenAI and how they were able to train a robotic hand to, I believe, solve a Rubik's Cube without ever actually training it in the physical world, only ever having been trained in a simulated environment. That is, again, this is the kind of innovation that we need, and the cloud can enable this kind of innovation.
Absolutely.
Whereas, this kind of machine learning inference or deep learning inference, which isn't as computationally expensive, can now be done at the edge. We're seeing a lot of innovation on the hardware front even to make this possible. Take a look at the neural engine on the iPhones. You take a look at the Google Edge TPUs or things like this, enabling at least some machine learning to be done at the edge where the data is. Last episode we were talking about how data has more gravity, so we don't want to be moving data to where the AI is. We want to be moving AI to where the data is, and edge computing enables us to do that.
My friends at Amazon, they talk about why to do the computing at the edge, and it's I'm trying to remember. So there's physics, right? So can I move that data? Can I move it at the right bandwidth, the right volume, the right speed, and reliability? There's the economics, so there's economics, so there's law of physics, there's the law of economics. So if I can move it to the cloud, does it make economic business sense to do so? And a university published a really interesting study where they had taken the AWS and the Azure tools, and they had done audio analytics and video analytics in the cloud and at the edge, and then they compared the total cost. And what they found is not only was it faster at the edge, but it was also 8 times cheaper.
Oh.
So using AWS tool, using Azure tools, doing it on your own compute hardware locally was 8 times cheaper, the total cost.
Wow.
And then the third is the law of the land. So, what's the laws in terms of regulatory, legislative law, but also socially accepted norms around privacy and other kinds of things. So even if you could you know, with, even if you could physically move it to the cloud, even if you could economically move it to the cloud, from a privacy perspective, is it better to bring it to the cloud where it can live forever and analyze it, or analyze it in situ in the moment and then take the results of that but throw away the data, right? So think about, if you're doing a worker safety thing, you want to know, are there any humans in an exclusion zone, but do you want to be doing facial recognition as part of that? So you get into some of these topics.
Interesting. And you're right. There's, of course, the economical and the physical aspect of it, but then there's also the marketing in a way standpoint and the privacy standpoint, saying,
Sure.
how amazing would it be if we could tell everybody that our phones do facial recognition entirely locally and all your face data is stored within an entirely dedicated secure enclave chip,
Exactly.
right?
Exactly.
Being able to say that, and also just having that privacy itself, adds a lot of value to the product and a lot of value to the service. So there's, just like as with everything else, there's tons of different factors to take into account. Everything has its own weight, and everything requires its own decisions.
Yep.
But really, it comes down to: is it economical to be running? Is it feasible
Sure.
to be running it
And
locally or in the cloud?
one of the things that we do to help, so my company, ADLINK, so the company was founded doing analog to digital 25 years ago. Okay? And so we do a lot of these, we make these data acquisition devices for scientific and other things. So we're doing, millions of samples per second from analog to 24-bit digital. So very high resolution, very high frequency sampling. And so to support that, you need to compute. So very early, we got into how do you do high performance edge compute? How do you do it small form factors? How do you do it rugged? And that's how you see today things like, ADLINK were built into every GE train, we're in every Deere autonomous tractor, we're in the ABDs, the Denso, we're in a lot of, the Raytheon, Lockheed, Boeing, Airbus, blah, 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 right? All these kinds of things. And so we have a really interesting portfolio where we go all the way from things as small as a so we go all the way from things as small as like these small prototyping boards, right? With that the compute is smaller than a credit card, right?
Wow.
And we manufacture like this compute, dozens of different ones using, NXP, Rockchip, Intel, Qualcomm, all kinds of different compute power budgets. But we go all the way from things as small as this to things like a box that has 40,000 NVIDIA CUDA cores and Dur Xeon in a box, right?
Wow.
We make another box that has 56 Xeon CPUs in a box.
That is incredible.
Can do an amazing amount of signal processing, or you can use it to heat your home.
Yeah, a friend of mine does that with the GPUs and the CPUs he's got running.
Yeah. So, we're, really tight friends manufacturing partner for NVIDIA, for Intel, but everything we do, like we don't make stuff for the data center, we don't make stuff for offices. Everything we do is manufactured to be in, on, or near the thing at the edge.
Wow.
So, there's 400,000 cameras connected to our vision systems. We're coming out with a small, rugged industrial camera that has an NVIDIA Xavier GPU built into the camera. And we do a lot around the robotics. So you look at, we were talking about the open robotics. So we actually design hardware specifically for robotics applications, and we give technical support and training for ROS for people using that. So, this is a physical hardware product, but it's been designed from the ground up and optimized for the needs of the open source and all of the I/O that you would typically have on a robot. And and some of it's pretty fun too. Like this is a new bit we came out with, which is this is a NVIDIA Xavier, but where it gets interesting is these are GMSL2 serial camera connections. So 3 gigabit per second serial camera connections. You connect them with a little coax cable out to 15 meters.
Mm-hmm.
And the reason it has 8 instead of 6 is I was helping an autonomous agriculture vehicle company that needed 360-degree stereo vision in 4K HDR.
Wow.
Yeah.
That is some incredible compute that you
Yeah.
can get at the edge.
So we do fun stuff, and it's a lot of fun for me coming from IBM to a company that not only do we have serious open source chops and we do a ton of contribution to the community, but we own our own factories and we make really amazing stuff.
Wow. That again, thank you for sharing all of this. This is really fun stuff. Now, I do want to ask you a little bit more of a fun question, but before I do that, I quickly want to address some questions from the live stream.
Sure.
First of all, I do see a question about whether or not robotics will overtake humanity. We can touch upon that a little bit more, but if you go back a couple of minutes, I was talking about the conversation between Neil and Jill on LinkedIn,
Sure.
and I think that does answer quite a bit of your question. Also, Tassin's asking, what if robots could teach students in school instead of teachers? Two things to say about that. First of all, we actually have a dedicated episode on education in the TechLifeSkills series. So if you just go a few episodes back, there is a dedicated education episode, so you can take a look at that. But also, really quickly, I feel like for all the questions, it would be important to make the distinction between hardware and software a little bit more clearly. Because this is exactly what I was referring to back when I mentioned that, people don't completely understand the world of robotics. As in, when we got a question, for example, could robots simulate emotions? And I feel like you should really make that distinction between the AI and the ML and the software versus the robot that happens to be the platform on which that software runs. Right?
And those platforms may or may not look like things you think of as a robot.
Exactly. And so a good analogy might be, your iPhone has iMessage on it, right? And that's one of the main reasons people buy iPhones. Now, in theory, technically, if they were to make it possible, a Samsung phone could quite as easily run iOS as an iPhone. Maybe not as well, but iMessage would still run on a Samsung phone. There's no technical reason why that hardware would be incapable of doing so. The only thing is that this iPhone happens to be the hardware on which iOS runs. iMessage is an iOS thing, not an iPhone thing, and iPhone happens to be the only thing running iOS. So when you talk about...
And you're not old enough to remember this, but once upon a time, Apple used to license their operating system to third-party manufacturers, so you could buy other products
with like iTunes and stuff.
Before iTunes, like I said, you're not old enough.
Okay.
I've known you for half of your career, so that would be since you were 12, I guess.
Yeah.
But you go back further, but yeah, it's they actually used to let you license and run it on other things.
That is an interesting little piece of history. So, yeah, thanks for letting me know. But yeah, so the idea is that within even the world of robotics, make that distinction between emotion, which is something that's software regulated, something that's implemented, but can be put onto any piece of software. Hardware versus something that's a hardware thing. Like, can we not necessarily make them feel emotions, but how can we represent those emotions on that hardware, right? So there's that distinction that I think is really important to make. I personally, first of all, to sort of answer your question, don't believe that we'll be simulating emotions or sentience within robots or AI technology in general. If you want to know more about that, take a look at the very first episode of Tech Time with Tanmay, or the last episode of Tech Life Skills with Tanmay, where we talked to Sriram and Ruchir. We talk quite a bit about that, where why I don't think AI machine learning is going to reach that level. But now, before we answer some more questions from the audience, we're getting a lot. I do want to quickly ask you, Joe, I know there's lots of fun examples of robotics technology that you've shared with me. One of them that we talked about before was helping baseball teams practice more efficiently, recreating pitches. Can you tell me a bit more about that?
I love that one. In fact, I'll even show something here. So let me just preface this saying, uh, in professional sports, they have a problem. Okay, it's called not being able to train at full speed. So just for sake of argument, if you are the world's best athlete in a sport, who do you train against? Because no matter who it is, your training partner is not as good at you as you, so you cannot train to the full limit of your ability. And this is one of the issues in Major League Baseball, that you can't be using your top pitchers to throw practice hits for your batting staff, because a professional pitcher, they only have so many pitches in a career. Their shoulder only has a finite number of pitches in their shoulder before it's worn out. So you can't be using them for that. And so there are pitching machines, but they don't really do that much, right? They spit a fastball, not much else. So these folks, so Josh, Roland, these folks at Traject Sports, which is a spinoff from what's his name, Professor John Phelps. It's like the University of Waterloo biomechanics something sports lab. So they've actually developed a robot to be able to accurately reproduce any pitch that a human can throw, and this can pitch a baseball. It can shoot tennis balls. It can bowl a wicket. It can do cricket. But they really focus in on the baseball. So think about having, and one of the things that makes it possible is because so much telemetry has been collected from pitches. So imagine if the Blue Jays are going to go play the Red Sox. What if they could be hitting perfectly recreated pitches of the Red Sox pitching staff all week long before they go into the game? And so let me go ahead and just show you a little bit of that. So this is, I got their permission to show this to you today. So the ball gets loaded into the robot, it gets aligned, and you see it has a 3 turning wheels, but what you can't see is that there are dozens of stepper motors and stabilizers built into this, so that these wheels, the motion they impart and what angle, and they basically have the mass to be able to work backwards from any pitch that's been thrown in a major league game to generate the stepper motor instructions to recreate that exact pitch. And as the ball is exiting the machine, there is an extremely high performance camera, let's just call it thousands of frames per second, that is capturing the ball as it leaves, and it's actually counting stitches and is telling them what is the rotation on this ball and the angular velocity in the ball.
That is incredible.
Yeah, it's really amazing. So think about being able to accurately recreate anything from an 87-mile-an-hour curveball to a 105-mile-an-hour fastball, and being able to land it within a few centimeter patch.
That is really incredible. Yeah, we're going to see some innovation within practicing baseball this way. And I feel like a very, very good analogy is AlphaZero. And if you look at what AlphaZero has enabled us to do, before, like, we had some of the best Go players in the world, they had nobody to really practice against, you're right, in order to sort of improve their skill level, and humans sort of started to plateau at 9D. And the issue with that is that, well, humans have reached a limit, right? We don't know how to increase further from here. But when we enabled AlphaZero to reach, forget superhuman, this was just out of this universe performance at Go, right? At that point, we started to see humans starting to improve their performance by gaining inspiration against this godly Go-playing agent, right?
Right.
And now we're going to start to see something similar in baseball, I hope, where we're going to start to see different teams using this technology.
Absolutely.
Increasing their performance by orders of magnitude because of the fact that they now have this technology to help them practice. So
it really will, right? if all the athletes can practice at full speed, practice at the top of their game, it is going to improve their performance. And it'll do some interesting things, right? You think about the Blue Jays going in and they're hitting perfectly recreated pitches of the Red Sox all week long before they go into the game. That's pretty exciting. And also the software that's running in this, they're running Open Robotics ROS 2 with Eclipse Cyclone DDS, which is the exact same software that you can run in all the way from a Roomba to an autonomous forklift to a vehicle, passenger vehicle. Yeah, wow. It's the same software. And they're running it on the ADLINK ROS Cube controller that I showed you. And all of these stepper motors and things, like this is off-the-shelf industrial technology, right? I love that they're using the sensors, the actuators, the hardware, the compute, the software, the same stuff that we use every day on a factory floor. They've taken and repurposed it for a completely different, amazing application. But it is an application in precision robotics, right? So somebody says, well, Joe, do you feel this technology could do the thing I need on a factory floor? You say, I don't know. Is it more complicated than throwing an 87-mile-an-hour curveball and landing it in a few centimeters?
First of all, it just goes to show the power of open source, that all these different technologies are powered by that same platform. But also, that is an amazing way to put whether or not a certain application is feasible for robotics technology. I feel like that analogy, people just get it after you give that analogy. Wonderful. All right, so now first of all, Anmol has a question: are robots going to make us lazier? Is it bad for us? The same calculator example. If you just scroll back by a couple of minutes, we talked about that during our conversation, during our thoughts on the conversation between Neil and Jill. So feel free to take a look at that. If you have more questions, though, feel free to put them in the chat, and we'd love to answer them. Akash Gupta is also asking, have we discussed OpenAI GPT-3? Not in this episode, but we will be in a future episode about things related to GPT-3. So stay tuned for that, but not just yet. Now, all right, let's see. We have another question from Tassin, actually. So,
hi, Tassin.
Yeah. So Tassin's asking, how can robots?
Tassin.
Yeah. So Tassin's asking, how can robots help in the COVID situation? We'll start with that question. He has another one, but let's start with that one. How can robots help us with COVID?
Yeah, and they already are in so many big ways. So around the whole COVID topic, if taken out of context, it might not sound quite right, but so my basic assertion is that in terms of the trends, COVID changes nothing. The trends are what they are. What COVID does is it screws with the timelines, okay? So you see some trends are slowed or even stalled by COVID. So things like autonomous passenger vehicle programs, especially autonomous public transportation, there's some slowdown there because nobody's getting on buses. But then you have others like autonomous delivery programs, right? Autonomous cargo delivery packages, in factory, in warehouse, AGVs, AMRs, all these things. Like on the autonomous delivery, we see things like customers of ours where they say, well, this was going to be a 2-year program, but now we want to figure out how to do it in 6 months instead, right? So there's this radical acceleration. My friend Damien the Clerk, he's in Europe and works with a company called Neolix that does these autonomous delivery robots. It was something like a 20 times increase in orders for the robot in 90 days because of COVID.
Wow.
20x, not 20%, 20 times. 2,000% increase in orders. So, so you see a lot of that. So a lot around the material movement, whether you're talking about, packages to your front door, last mile scenario, or moving material in a warehouse and factory, things like BMW and others are doing, where you're picking up material from one place in one building, navigating it out of the building, down a street, into another building to deliver to the manufacturing line at the exact correct moment, like all that. because manufacturing a system of systems, all that coordination, the synchronization, very impressive. And then there's the ones you see in the news around, typically around the some of the service functions, the cleaning, right? So you look at the floor cleaning and other kinds of robots that Brain has already been doing for years, but now this accelerates what Brain Corp is doing. You look at UVD robotics and the things that they're doing, where it's people who were doing submersible autonomous robotics, and now they're making ultraviolet robots that roll around schools and stores. And then the service robots. So things like we've already been for years. We've been involved already in things like you're in a hotel, you order room service, a robot brings it to your door. The demand for that has exploded. And what's interesting is one of the trends that COVID has accelerated is the public's acceptance or even happiness with being served by robots. Okay, so whereas in the past people might resist and say, I don't want a robot bringing my meal, I don't want a robot bringing my package, people are kind of happy with it now. It's like, oh, cool. No human hands have touched this thing. It's just been delivered by a robot. Like, people are really happy about that, and I think that that's going to be a bit sticky. That even after we get through this situation, I think a lot of that will stick around. I think it also helps that a lot of people have just in the design of the robots, that when you design robots for industrial functions, or you design a robot to interact with humans and the general public, very different design philosophies. And that's how you get things like accessible Ollie is from a industrial design perspective. It's like the industrial design equivalent of Hello Kitty, right? Like, you look at the accessible Ollie bus, and the headlights, the under the front bumper, it makes like a little smiley face, and you see a lot of those cues. Also, as very well known, very well documented, if you put eyes, especially googly eyes, on any robot at all, anywhere, everyone immediately loves it. And so that's why you see things all the way from autonomous people movers down to delivery robots where they put eyes on the robot.
That is really interesting. Googly eyes.
Mimicking human eyes.
Yeah.
I should say human eyes, but really it's more like, Hello Kitty eyes, like big eyes.
Yeah.
Anime eyes.
Yeah. The ones that our brains are like, oh, that's cute. We need to like this. The ones that triggered
exactly.
that primal response, right?
So, very soft edges, no sharp corners, a lot of whites and pastels.
Yeah.
That's the design language.
A lot of this is psychological too.
Very much so.
Yeah, very interesting, because we need people to be able to adapt to it. We need people to be able to accept this new technology in their life playing such a large role. And you're right, COVID has sort of accelerated some trends, it's slowed down some, but overall it's sort of forcing us to innovate just like it is in every other field.
And it's done a lot for removing some societal and regulatory barriers, right? Where for a lot of these programs, like in terms of autonomous delivery, it has done much to cause legislatures, even at the local level, to remove impediments for this kind of autonomy.
Very nice. It's almost weird how it took a pandemic for us to realize how we shouldn't be stifling innovation like this, and how we should be adapting to technology as we sort of come as sort of comes up.
And how fragile all of these supply chains are.
Yes.
It's so my friends at Local Motors, their founder CEO Jay Rogers, like amazing individual, amazing vision, but what he always wanted to do is, how do you move the design, manufacturing, and service functions to be closer to the point where the goods are actually consumed. So his vision is microfactories, a microfactory in each city that has local design, manufacturing, and service of a product that is uniquely suited for that location's needs.
Hmm.
I think with direct digital manufacturing, you're going to see a lot of that, of manufacturing coming back onshore to countries, and the manufacturing being much more flexible because it is in fact digitized. Where instead of a million square feet to make one product, we start to get into things of like, you know, within tens of thousands of square feet, I can make many different products. So yeah, I think you're going to see a lot of what we at ADLINK do, which is called high mix, low volume manufacturing. So, we're not Dell, we're not Bosch, where you're making like a million units of one thing. Instead, what we do is we make a amazing variety of different things, but in relatively small volumes, right? So
Hmm.
for us, volumes is, you know, hundreds, thousands, tens of thousands. We have the occasional product that's like 100,000 or a million units,
Hmm.
but sweet spot for us is typically in that very high mix, low volume. And,
Very
and
nice.
you're going to see a lot more of that, and you're going to see a lot more of it onshore.
That's really interesting to hear because, you know, especially with Edge, you need a very high variety of products to be able to
Hmm.
suit all the different use cases where people are going to
Sure.
be applying your products, right? People could be
What
applying it.
my form factor, my compute, my thermals, the environmental, all of these things.
Very nice. And being able to fine tune and adapt all the way down from, being able to manufacture the best compute for edge computing and be able to manufacture all the different products for, specific regions or specific
Hmm.
geographies or based off the people that live there, what they need. I feel like you're right. That is really critical for us people to do, to be able to scale all these different services that we're providing, and we've
Yeah.
seen the importance of that through this pandemic. You're absolutely right, and robotics is going to help us achieve that level of scale.
Yeah. For me, with MQTT, I always had this thought of, uh, if we could instrument the manufacturing of a thing and then build smarts into it and have it be a connected product so that I know how it's made and then I know how it's used and how it performs and I know how it's serviced. You can do this complete closed loop so that the next one to come off the manufacturing line is better than the one before it. And and that's how I was thinking about it in terms of open source connected IoT machine to machine.
Mm-hmm.
So at ADLink, we not only do we do this open source software and contribute to it, but we actually manufacture the bit. So it's pretty fun for me to see that, you know, ADLink bits, ADLink hardware and software is being used in the manufacture of a thing that contains ADLink hardware and software.
Yeah, I'm sure that must be really fun to see. And I mean, it makes sense. Why, right? We've already talked about the fact that data has more gravity than other technologies like AI or machine learning, whatever it could be. It could be signal processing, whatever. We want to move the tech to the data, not the data to the tech. So, I feel like, there's so many different analogies in the world. Again, one could be the way our computers work. You'd be surprised. I mean, for the developers watching the show, you'd be surprised just how slow RAM is. A lot of the time, what you want to do is you want to be able to store as much of your data as possible within contiguous blocks of memory that you load into cache, modifying cache, and then bring back to memory instead of continuously invalidating cache lines because that makes your program really, really slow. You want the data near the compute. You want the compute near the data, not the other way around. And so,
Absolutely.
it's really interesting.
We're working on a thing with Bosch so that for the Eclipse Cyclone DDS, like say you're working with lidar point clouds, right, or cameras, right? So image data, like these are big messages, and you think like 10 million point clouds, and so we're working with Bosch around this zero copy shared memory pub sub. So think about being able to um, have a lidar point cloud, and via the publish subscribe, you're basically you create what's called a loaned message, where it's in shared memory, and you're handing around the pointer. So you can take this point cloud and publish it to like a half dozen different analytics pipelines,
Hmm.
but you never make a copy of the data.
That is
Okay.
amazing.
Yeah. So in some early benchmarking we've done, so think about being able to do publish, subscribe, uh, much like you would do in MQTT or JMS or any of these pub sub frameworks. But in open robotics and autonomous vehicle, do pub sub of lidar point clouds and images at 12 gigabytes per second on a Xeon, which is quite performant.
Mm-hmm.
And then, and then, and then we're working on something with our friends at the Lightly, where they've actually developed a publish subscribe a they developed a publish subscribe FPGA,
Okay.
and just want to show you one thing, thought it was rather interesting. So in robotics, things like jitter and skew are the enemy of being able to have safe robotics.
Mm-hmm.
So what if instead of doing publish subscribe in software, I actually could do it in an FPGA?
Wow.
And so the latency is good. The latency is impressive. What's even more incredible is the absolute lack of jitter.
Wow.
Okay. So you think about, for real-time functionally safe, you need deterministic, you need predictable, reliable.
Mm-hmm.
So being able to take my data and publish it to many different processes, okay, so inter-process, many different systems, so inter-computer, and to do it with what is effectively a complete absence of skew and jitter.
Wow. That's incredible because there's so many use cases from the world of machine learning to robotics where you want that deterministic latency, right? You don't want you don't want skew in machine learning, and of course robotics happens to be one of the cases where it's really important not to. And technology like FPGAs and custom silicon is going to help us do that.
Yep. And the first inquiry I got from this is folks in a just call it race car stuff.
I actually just saw a comment on the YouTube as we were looking at that, and he says, "Gosh, that's nanoseconds, not milliseconds." And I must admit, when I looked at that graph, the first thing I saw was an M, and I was like, "Okay, 4.5 seconds, not bad." And then after I saw that comment, I looked at the graphic again. I was like, "Oh wait, that's nanoseconds." And so yeah, that's super impressive. Seeing.
So for the things we work on around aerospace and military and industrial, a millisecond is slow.
Yeah.
For some of the things that we're involved in, that's an eternity. So we see people doing, people are so impressed or amazed that they can do things like 500 hertz control loops with the open source Eclipse Cyclone DDS and robots, and we're like, well, of course you can. That's slow.
Yeah. That's just incredible because you don't think your mind, when it looks at 4500 and it looks at performance, the first thing that comes to your mind initially, at least because of the stuff that I work with, is milliseconds. But then in your case, your specific applications need that nanosecond level latency, and when you look at that again, you're like, oh wait, wow, that's nanoseconds. And the fact that you can get such consistent latency at the nanosecond level, that's what's really impressive, right? Getting at the millisecond level isn't that hard. I mean, it's a lot easier, but down to that nanosecond level, being able to predict when exactly you're going to get results from whatever it is that you want to do, that's pretty incredible. Now
what's happening is we're working to build support for the. So we're working together with the FPGA maker to build that into the open source Eclipse Cyclone. So between the work with Bosch, doing these big point clouds, 12 gigabyte per second, working with light fleet, so you can do pub/slub with all the normal kind of DDS quality of service in open robotics on autonomous vehicle, but to have that complete absence of skew and jitter. I think there's some really exciting things coming in. I'm a messaging nerd, right? So if you want to see a through line for my whole career, it's always been around messaging and pub/sub. So whether it was B2B trading networks and crypto for military, and MQTT, and enterprise service buses, and now in open robotics and autonomous vehicles with the DDS. And there's something coming, something new called Zeno. So think think like, MQTT is a brokered protocol. So think like even smaller, more efficient than MQTT, integrated with the Eclipse Cyclone DDS, so that swarms of robots and even like 16-bit microcontrollers can auto-discover each other and have coordinated functions. And I think it also has implication for vehicle to vehicle. So vehicle to vehicles, think of it as just a larger swarm of robots moving at higher speeds. Yeah,
Very interesting.
It's really cool stuff.
It really is. It really is. And I've always been really fascinated by the world of like low level tech and FPGAs and the world of like ASICs and down to that silicon level and seeing the impact that that has not only on like software like AI and stuff, but even down to robotics. It's really fascinating to see. Just goes to show that power of the innovation that you can get when everybody's working together in an open source fashion. Now, before we continue, there is one last question that I want to get through the live stream. We are edging close to the end of today's session, so we're going to keep this one quick. But Tassin asks again, can robots, or how can robots, help humans in disasters like earthquakes and large fires?
Sure. The so right now, if you look at, so I guess I'll say how they're used today and what's coming. Yeah.
Sure.
So certainly, UAVs, drones, that's had a huge impact, right? For being able to quickly find things. There's a lot around, not just robots, but in terms of perception. So things like, ground penetrating radar with the ML, the intelligence to make sense of what you see, so you can find people. The DSRC Hubo and a lot of these other programs where you get into robots that are rather agile, that can deal with broken ground. Okay, so that's an area where UAVs has an advantage because they're flying, but then UAVs typically don't enter spaces. But you look at like things that friends at Boston Dynamics do with Spot and others, really quite agile. Robots. You look at things that our friends at Robotics do, where they have an IP67 waterproof tracked robot that can go up and down stairs, and it has titanium axles and is drop tested from 2 stories. So if you toss it out a second floor window, it can right itself and drive back up the stairs again.
Interesting.
And the DSRC Hubo. So, is that the exact form factor that's going to be used in these situations? Can't tell you, but definitely the lessons learned from that DARPA program for robotics in these disaster situations, you're going to see that roll out everywhere. And I think really the biggest thing is just the open source. So there's the combination of direct digital manufacturing and open source robotics allows people to build a prototype, to test a hypothesis, right? To do an experiment was previously very difficult, very expensive, took a long time. But if with direct digital manufacturing, 3D printing, and open robotics, I can very quickly, I can have an idea, I can 3D print a prototype, I can take off-the-shelf electronics, I can load in open robotics, and so it already knows SLAM navigation, it knows how to get around in the world, it knows how to work with the actuators, the servos. I can very quickly assemble that together, and I think that's where you're going to get a lot of non-traditional. So you already see things like the open source robotics, for lack of a better term, snakes, right? So, snakes are very good at wiggling into small places, and so you're seeing a lot of work being done on that kind of form factor, and it's because of these things.
Interesting. So we're going to see a lot of different combinations of software and hardware and different kinds of hardware and different form factors, different specializations in order to help us in these disasters with all sorts of things.
Absolutely.
And I feel like there are going to be lots of different initiatives, like for example IBM's Call for Code, that sort of catalyze the innovation within this field and enable it to scale.
And as long as we're talking about disasters, quick shout out to our friends at What 3 Words. So they've done a geoencoding. They break the entire planet into 3-meter squares, and every 3-meter squares gets a 3-word mnemonic. Okay, and so in terms of disaster relief, instead of people, like in Haiti, one of the problems with the earthquakes and hurricanes and things, whatever disasters, like street signs get knocked down, right? Like, so where am I? Where is it that I need to deliver the emergency supplies? Where do I need the personnel to go? If you can just remember, that it's whiskey, helicopter, puppy, right? Whatever the three-word mnemonic is, then that makes it very easy to communicate and coordinate. And so you now see, so that's some technology that the first vehicle was ever in was accessible Ollie, and then you have BMW. Well, with BMW, certainly Mercedes was the first commercial vehicle to incorporate, but that's a big thing. So think about, if you can just verbally say, the three-word mnemonic of where you are and where you are that you need help, and then that can be understood and interpreted by the AI to then deliver the autonomous robotic or UAV. And this is very easy technology. So one of the engineers on Accessible Ollie, he basically in a day he integrated it so he could just speak the three words, and his UAV would take off, fly, and go to that location.
Very nice. That is, this technology is so impactful, not only because it can do so much, and because it has such an impact on people's lives, but also because it's easy enough for us to be able to integrate it in any technology. The barrier of entry is getting lower and lower, and that's thanks to the power, as you mentioned, of open source.
It's the democratization of technology.
Yes, exactly. Like, why do we have so much innovation in machine learning today? It's because we've democratized access to compute power, so that anybody can just go to the cloud, spin up 8 Tesla V100s just like that, start training their neural networks. They have an amazing idea, right? Previously, that would require you to buy each GPU like $10,000 each with all the CPUs and all the RAM that you need. You're not going to do that in the cloud.
One of the issues there, though, is so there's a pattern that's emerged, which is Joe discovers a technology, a startup in a technology, falls in love with it, starts using it, and then Apple buys them and they disappear from public view. So it's happened to me like a half dozen times so far. Yeah, and so now, like, the folks that contribute to YOLO and the XNOR, which is how do you do machine learning on constrained compute, they've been acquired by Apple.
Really? Even the YOLO guys? I did not know that. Wow. Well, I mean, I can see why.
YOLO will have a life of its own, so YOLO will be okay, but yeah.
Fascinating. Well, I mean, first of all, Joe, thank you very much for your insights. I really appreciate them. This has been really fascinating. If anybody else has any more questions, feel free to put them in the comments of the replay of the live stream. We'll definitely get back to them. But before we go today, Joe, I do want to ask you, is there a closing message you'd like to share with the audience today?
Yeah, really just collaborate, be generous, contribute, and that's how we're going to tackle these things. And that was our premise around Accessible Ollie, is here's a problem that's so big, so intractable that no individual, no company, no organization can solve it, but that together we can really do something. So get engaged, pick a topic, pick a passion, and give.
Thank you very much, Joe. That is an exceptional message. Be generous, contribute, work with the community. I love it. You've had some really unique takes on the show today, all the way from something that takes a minute to get your head around, scaling from a Roomba to an autonomous car with the autonomous forklift, and so many, like an infinite number of things in between them, in that spectrum, scaling everything up from risk and compute and complexity, and how we talked about the importance of open source, especially in the world of robotics technology. Again, it's been some really fascinating content. Thank you very much for joining. It was an honor to have you on the show. I'm sure that just as I have, the audience has found this discussion really invaluable. But I would also like to say a huge thank you to everybody that's actually joining the live stream today. Now, do remember, these live streams are held in the morning. Yes, thank you. Every Sunday, Eastern time. And so make sure you join us next week as well, when we're going to be covering the intersection of marketing and technology. And so thank you very much, Joe. It was an honor to have you on the show. Thank you, everybody, for joining in today, and goodbye.